So good day everyone. Today we'll do Augmented Matrix and Gaussian Elimination. So before I start, I would like to give credits to Dr. Jong Vasquez for developing the module on the left. No copyright infringement is intended by recording this video. This video is only for educational purposes. So what is an augmented matrix? If A is a M by N matrix and B is a P by N matrix, then the augmented matrix of A and B, denoted by square brackets as A and B, then between them meron kang colon, this one, okay, is the matrix formed by the elements of A and B separated by pipes. So essentially, ang ginawa natin is pareho yung number of rows nila, pinagtabi natin yung dalawa, A and B, and sineperate natin siya with straight lines. Yung tawag niya na pipes. Augmented matrix AB, ito siya. So, augmented matrix A is a 3 by 3 matrix. This is a 2 by 3 matrix, 2 by 3, or 3, or 2 by 3 matrix. Okay? Then, AB is this one. 1, negative 2, 5, 1, negative 5, negative 2, 1, negative 1. So, pinagtabi lang natin siya. Yun lang yung augmented matrix. Okay? For the system of linear equations, if we have yung AX equals B natin, augmented matrix natin meron tayo AX is equal to B. If we want to represent this in the augmented matrix form, then yung augmented matrix niyan is yung augmented matrix ni A and ni B. Yung sa coefficients natin and yung column matrix of our constants, AB. So for example here, okay, example dito, 2, negative 1, 3, 1, 2, 6, negative 2, 4, 1, x, y, z. So ito yung A, x, B. Okay? A, x, and B. Yung augmented matrix na kunin mo lang to si A and si B, kunin mo siyang A colon B or A pipes B na augmented. Okay? So how do we then use this to solve our system of electrons? Before we proceed to that, first we need to know about the echelon form of matrix. So in M by N matrix, A is said to be in row echelon form if it satisfies the following properties. First properties, all rows whose elements are all zeros, if exist, are at the bottom of the matrix. Second property, if at least one element on a row not equal to 0, the first non-zero element should be 1, and this is called the leading entry of the row. And third, if two successive rows of the matrix have leading entries, the entry of the row below the other row must appear to the right of the leading entry of the other row. Furthermore, an M by N matrix A is said to be in reduced row echelon form. Iba tong reduced row echelon form, it's a special kind of row echelon form, okay? This reduced row echelon form. If added to this additional three properties, it satisfies a property in which if a column contains a leading entry of some row, then all the other entries must be equal to 0. Again, if a column contains a leading entry of some row, then all the other entries must be 0. So to know whether a matrix or not is in row echelon form and in reduced row echelon form, we apply these rules when we look at the matrix. So for example, yung matrix A, B, and C are not in row echelon form. So why not? So for matrix A, makita natin, meron tayong row na lahat 0. Okay? Sa rule 1 natin, all rows whose elements are all zeros if exist are at the bottom of the matrix. So dapat daw, itong row na to, nasa bottom siya ng matrix if this is in row echelon form. So if we want to make A in row echelon form, let's say, gusto nating kumuha ng matrix na similar kay A na row echelon form, what we can do is 1, 2, 0, negative 1, 3, 2, 0, 1, 0, 1, negative 3, negative 3, 5, 0, 0, 0, 1, 9, 2. Then, we can swap itong dalawa. Okay? We can put the 0 matrix at the bottom. 0, 0, 0, 0, 0, 0, sorry, the 0 row. And 0, 0, 0, 0, 0, 1. So, this one, itong matrix na to, ito, naka-row echelon form yan. So, bakit naka-row echelon form yan? All rows whose elements are all 0 exist are at the bottom of the matrix. This. If at least one element on a row is not equal to 0, the first non-zero element is 1. First non-zero element of all the rows is 1. 1, 1, 1, 1. Okay? And if two successive rows of the matrix have leading entries, the leading entry of the row below the other row must appear to the right of the leading entry of the other row. So, ito yung first leading entry natin. Yung next leading entry daw dapat nasa kanan ng row niya. Is this one. Then we go down again. We go down here. Ito. Nasa kanan. Itong next leading entry natin. This one. 1, 2. Nasa right niya. Then itong last one. Nasa right din siya. Nandito. So this is in row echelon form. Okay. Now let's look at B and C. So for matrix B, this one is not in row echelon form because this does not satisfy the second rule. If at least one element on a row is not equal to 0, the first non-zero element should be 1. Yung third row natin, negative 1 yung first non-zero element. So, dapat maging 1 yan para maging row echelon form to. First row, 1 yung una. Second row, 1 yung una. Fourth row, 1 yung una. Okay? And for letter C, okay, this is not in row echelon form because if makita natin, first leading entry, lahat ng leading entries mo, lahat ng first entries ng row mo, 1 sila lahat. Okay? Then wala naman tayong rows na puro 0. But if we look at rule 3, if two successive rows of the matrix have leading entries, the leading entry of the row below the other row must appear to the right of the leading entry of the other row. If we look at rows 3 and 4, okay, natin yung C. 1, 2, 2, negative 4, 0, 1, 6, negative 7, 0, 0, 1, 8, and 0, 1, 0, 0. Row 1, row 2 dissatisfies yung rule 3 natin. So, check yan. Check. Okay. Row 2 to row 3, yung leading entry ni row 3 is nasa right ni row 2. Check pa rin. Pero pagdating natin sa row 3 and row 4, okay, yung row 4 natin, yung leading entry niya nasa second column. Nandito. Pero yung leading entry ng third row natin, nasa third column. It's not to the right. Yung first non-zero, not to the right. So this is not in row echelon form. Now let's look at other examples. Okay. For row D, for matrix D, this matrix is in row echelon form. Okay. Because all of the leading entries are 1. Wala namang 0 lahat nung bottom rows. Okay. Wala naman 0 lahat yung rows. And lahat ng leading entry is to the right. Same with E. And same with F. Okay? Lahat yan is naka-row echelon form. But this is not in reduced row echelon form because it does not satisfy condition 4. In which if a column consists a leading entry of some row, then all the other entries must be 0. So if we look at all of the leading entries, 1, 2, 3, 4, for letter D, ito, itong nasa diagonal natin, ito, this one, this one, this one, and this one. For this to be in reduced row echelon form, dapat daw, lahat ng other elements in that column in which this leading row is in should be 0. So dito, 1 is a leading entry. In its column, we have 2, 0, 0. Dahil meron kang 2 dito, yung column niya, hindi lahat 0 except for this leading entry. So this is not in reduced row echelon form. Same with this one. Yung sa E, you have itong 1 na to, itong 1 na to, and itong 1 na to as yung ating leading entries. Okay? This one, this one, and this one. For the first column in which this first leading entry is in, lahat 0. So check. Second column in which the second leading entry is in, lahat 0. Check. Pero dito sa third, makita natin itong negative 5 mo, hindi siya 0. Sa column na meron tayong leading entry na 1. So this is not in reduced row echelon form. But it is still in row echelon form because it satisfies rules 1 to 3. And same dito sa ating matrix F. 1, 0, 0, 0, 0, 0, 1, 0, 0, 0. Then leading entry 1. Okay. Leading entry yan. Leading entry to. Leading entry to. For this column, 0 lahat. For this column, 0 lahat. For the third column in which the third leading entry is in, meron tayong makita, meron kang 8 dyan. Yung 8 na yan, hindi siya 0. So this is not in reduced row echelon form. It's just in row echelon form. Okay? And finally, the following matrices, G, H, and J, are in reduced row echelon form. Hence, they are also in row echelon form. So for G, row echelon form yan because this satisfies 1 yung leading entry ng lahat. Okay? Leading entries natin, they're all 1. They're all 1. Okay? Then, the column in which these leading entries are in, 0 lahat ng entries mo. Same with this one. 1, 1, 1. Then, for all the columns in which the leading entries are, 0 lahat ng ibang entries. And for this one as well, kita natin, meron tayong dalawang leading entries sa J. This one in the first column, and this one in the second column. 0 lahat sa first column, 0 lahat sa second column except for the ones. Sa third column natin, wala naman tayong leading entry kasi puro 0 na lang yan. So, pwede na tayong magkaroon ng value dyan na non-zero, which is itong negative 3. So, this is still in reduced row echelon form. Okay? So, as a note, yung row echelon form natin, pwede rin natin yung apply to our augmented matrices. And gagamitin natin yung row echelon form and itong reduced row echelon form natin para mas mapadali natin yung pag-solve ng ating systems of equations mo. So next, for our systems of linear equations, again, kaya nga natin inaral itong row echelon form, we want to transform our augmented matrices AB that represent our system of equation into this row echelon form. Okay? And we do that by using elementary row operations to this system or to this augmented matrix. As applied to augmented matrix AB as a system of equation, the 3 elementary row operations will correspond to the following. Type 1 is rearranging the order of the equations. Type 2 is multiplying both sides of the equation by a constant, and type 3 is working with 2 operations. Okay? From this observation, we could see that that as applied to its operations does not alter the solution of the system. So if we do itong operations na to sa ating system of equation, hindi dapat magbabago ang value ng hinanap natin na x, y, z, x1, x2, x3, and so on. Okay? So we can apply yung ating row operations na naaral natin before. It is somewhere. Okay? Itong elementary row operations natin, yung interchanging any two rows, multiplying a row by a non-zero constant k, and adding elements of row k to the elements of another row. Elements to a row of k times of the elements of another row correspondingly, yung types 1, 2, and 3 operations natin, para matransform natin yung ating original matrix into something that is much simpler. Or yung augmented matrix natin na AB para ma-transform natin ultimately into the row echelon form. Okay? So row equivalent matrices, an M by N matrix A is row equivalent to an M by N matrix B if B can be obtained from A by applying a finite sequence of elementary row operations, which is yung kanina nating ginawa. Yung kanina nating pinakita or yung ginawa natin last time. So there are theorems on matrix equivalence. Every non-zero M by N matrix A is equal to Aij is row equivalent to a matrix in a row echelon form. Okay? So sinasabi niyan, lahat daw ng non-zero matrix na A, meron siyang row echelon form. Second, every non-zero matrix A that is row equivalent to a matrix in reduced row echelon form. Or, pwede raw tayo makahanap ng matrix na reduced row echelon form for matrix A. Then, if we have AX equals B and CX equals D, the two linear systems of equations with n unknowns, if the augmented matrices AB and CD are row equivalent, then the linear systems are equivalent. Okay? So if AB and CD are row equivalent daw, okay? Ibig sabihin yung X nila, pareho dapat. And gagamitin natin yung property na yan because what we'll do is we'll transform yung matrix natin na original or yung original nating augmented matrix or original nating systems of equations to something simpler. Something na row echelon form siya or reduced row echelon form siya. And as a corollary to the last theorem, if A and B are row equivalent matrices, then the homogeneous system AX equals 0 and BX equals 0 are equivalent. Okay? So knowing all of these, we can apply this later when we go into our Gaussian elimination. Okay? Kaya nating makasolve ng systems of M equations with M unknowns. So in general, a system of M equations with N unknowns, alam natin we can write it in the AX is equal to B notation. Pwede rin natin siyang i-represent in the augmented notation AB. Okay? And for our first method of solution, we can do ang tinatawag natin na Gaussian elimination. Gaussian elimination. The Gaussian elimination method natin, ang gusto natin magawa is yung augmented matrix natin na AB, we want to transform it into augmented matrix A star, B star, in which this augmented matrix is in row echelon form. Para ma-transform siya into row echelon form, we apply elementary row operations / transformations. Okay? After nating magawang row echelon form augmented matrix natin, we can use back substitution to give the values of our X matrix, which will be also the solution to our original matrix. So once we get this, we can solve for X. And yung solution ni X dito is same ng solution nung naan. Gaussian elimination is one of the easier methods to do for big matrices. Pag lumaki na yung matrix natin at sizes greater than, let's say, 3 by 3, or let's say mga 5 by 5, 6 by 6, 7 by 7, 10 by 10, 100 by 100, yung other methods natin medyo clunky na siya. But this one, medyo madali pa siya. The challenge here is to get the row echelon form. Okay? And to transform our augmented matrix to the row echelon form, we can apply the following steps. 1. Find the leftmost non-zero column. Okay? Second, if the first row has a zero in the column of step 1, interchange it with one that has a non-zero entry in the same column. Third, obtain zeros below the leading entry by adding suitable multiples of the top row and to the rows below that. And last, cover the top row and repeat the same steps for the rest of the rows. So medyo mahirap siyang i-follow pag hindi natin yung steps. Let's try solving a system of equation. So let's say we have the system of linear equation. X plus 2y plus 3z is equal to 9. 2x minus y plus z equal to 8. And we have 3x. So wala tayong y. So we can plus 0y minus z is equal. If we transform that into ax is equal to b form, we would have 1, 2, 3. So this corresponds to the coefficients. 2, negative 1, 0. And 3 plus niya. 1, negative 1. We have x, y, z. Ito yung unknowns natin. X, y, z. Equal siya sa 9, 8, 3. Yan yung ax equals to b. But further, we can transform that into augmented matrix. A, B na lang siya. A natin, 1, 2, 3. 2, negative 1, 1. 3, 0, negative 1. Then, separate it with pipes. Kunin mo yung B. 9, 8. Ito yung A, B form ng ating matrix. What we want to do now is itong A, B form natin, we want to transform that into our row echelon form. A asterisk, B asterisk, or B star. And to do that, we follow yung steps na naandito. So first, find the leftmost non-zero column. It's column 1. 1, 0. 1, 2, 3 may value. So if the first row has a 0 in the column of step 1, interchange it with one that has a non-zero entry in the same row. Wala namang may 0 dito. Okay? Hindi naman to 0. So, kebs yan. Then, we want to zero out yung entries below this leading entry. Okay? So, para maging row echelon form to, gusto natin itong 2 and 3, gusto natin matransform yan into 0. And how we'll do that is we'll apply our elementary row operation. We have 1, 2, 3, 9. Then we have 2, negative 1, 1, 8, and 3, 0, negative 1. So to transform that, okay, to transform 2 and 3 into 0, what we want to do, or what we're gonna do, is we're gonna be adding multiples of row 1, okay, ito yung row 1, into row 2 and row 3. Row 2 and row 3. To row 2, para mag-zero out itong 2 na to, we want to add multiples of row 1. Okay? So what we'll add is a negative 2. We're going to be adding negative 2 of row 1. Then for the third row, para mag-zero out to, gusto natin mag-minus ng 3. Para makuha yung 3 mula kay 1, we add negative 3 of row 1. Doing that, we will get the following. 1, 2, 3, 9. Okay. Then we have 2, 2, minus 2 times 1. Then we have negative 1 minus 2 times 2. Have 1 minus 2 times 3. And we have lastly, so hindi lang ito yung matatransform, ito rin. Kasi isang matrix na lang yan essentially. Would have 8 minus 2. Then kunin mo to times 9. Do that the same thing with our third row. 3 minus 3 times 1. We have 0. We have 0 minus 3 times 2. Then we have negative 1 minus 3, 3. Then dito sa baba, we have 3 minus 3, 9. If we do that, solving for that one, we would get 1, 9, 0, negative 1, minus 3, minus 4, have negative 5, 1 minus 6, have negative 5, and 8 minus 18, we would have negative 10. So please be careful with your arithmetic here because take 2 ko na to kasi nagkamali ako ng arithmetic kanina. Okay. And next, 3 minus 3, 0. 0 minus 6, we have negative 6. Negative 1 minus 9, we have negative 10. 3 minus 27, we have negative 20. Okay? So to transform yan, so hindi natin gagalawin to. Ito, puro 0 na lahat yan. So now we work on the second row. Okay? So since na-transform natin yung second row, iba na siya. Ito na yung ating R2 prime and R prime. What we want to do now is we want to make the leading entry of R2 prime into 1. Then we want to zero out lahat nung nasa ilalim nung leading entry ni R2 prime. Okay? So to do that, we have 1, 2, 3, 9. To make this into 1, we need to multiply R2 prime by negative 1 over 5 or divided by negative 5. Pag ginawa natin yon, we will have 0, 1, 1, 2. Okay? Then we have 0, negative 6, negative 10, negative 4. After which, we can now, okay? So since nabago to, ito na yung R2 double prime. What we can do now is itong R3 prime natin, gusto natin matransform into 0, itong negative 6 na to para maging row echelon form to. Okay? And to do that, we need to add, okay? We need to add 6 times of yung bago nating row prime. Okay? Add daw tayo ng 6 times nitong 1 na to dito para ma-zero out to. And do that operation for the same, for the other elements in this row, and we should get our row echelon form. And doing that, we have 1, 2, 3, 9. So notice yung top row natin, hindi na yan nagbabago, yan na yan talaga. We have 0, 1, 1, 2. Ito, hindi na rin magbabago yan. Second row. Third row, and rows below na lang yung mababago. We have 0 plus 6 times R2 prime, pero 0 lang siya. So 0 lang yan. We have negative 6. We have negative 6 plus 6 times 1. Kinuha natin itong 1 na to, dyan. Then we have negative 10 plus 6 times 1. Yung 1 na yan. And you have negative 24 plus 6 times 2. Yung 2, so yan. Okay? So, doing that operation, you should get 1, 2, 3, 9. Again, hindi nagbabago yung top row. Second row din, hindi nagbabago. Third row, we have 0, 0, negative 10 plus 6, negative 4, negative 24, plus 12, negative 12. Okay? Now, para ma-reduce natin to into row echelon form, or para magawa natin yung row echelon form, gusto natin gawin itong row 3 natin into 1 yung first entry. What we will do, we'll multiply this by negative 1/4 na to. Para this one, negative 4 maging 1 siya. And doing that, we would have 1, 2, 3, 9, 0, 1, 1, 0, 0, negative 4 times negative 1/4, you have 1, negative 12 times negative 1/4, you have. And obtaining this, we now obtain a row echelon for AB. And from the theorem kanina, alam natin, if yung solution XYZ ng AB row echelon form natin, itong bagong augmented matrix natin, nakuha natin, same lang dapat siya dun sa solution nung original AB natin or original system of linear equations natin. So, alam natin, itong 1, 2, 3, 9, 0, 1, 1, 2, 0, 0, 1, 3, if ginawa natin itong AX plus B form, it will be something like this. 1, 2, 3, 0, 1, 1, 0, 0, 1, X, Y, Z is equal to 9, 2, 3. Then, if we apply yung multiplication natin, malaman natin, X plus 2Y plus 3Z equal to 9. Y plus Z, 1Y plus 1Y plus 1Z is equal to 2. And we have 1Z is equal to 3. So, nakita natin, Z is equal to 3. Okay. First thing, Z is equal to 3. Then, by back substitute, paano mo gagawin yun? Yung Z lagay mo sa 3. Okay? And have Y plus 3 is equal to 2. Makita natin Y is equal to negative 1. Okay? So now we have a value for 3 and negative 1. Lagay natin dito sa expression sa taas. X minus 2 times 1 or plus 2 times negative 1. Okay? Plus 3 times 3 equal to 9. We'll have X is equal to 2. Okay? If tama yung ginawa natin, dapat makuha natin that X is equal to 2, Y is equal to negative 1, and Z is equal to 3. Then to confirm if tama ba yung nagawa natin, babalik natin ito 2, negative 1, and 3 sa original na AX equals B mo. Original wag dun sa ginawa nyo augmented matrix. So baka dun kayo nagbe-base. Okay? If babalik natin siya, we have okay? Yung original natin, we have X is equal to 2. Y is equal to negative 1. And Z is equal to 3. 2 minus 2 is 0. Plus 3 times 3, 9. Check. 2 times 2, 4. Minus negative 1, 5. Plus 3, 8. 3 times 2, 6. Plus 0 times negative 1, 6 pa rin. Minus 3, 3. So, nag-confirm siya. So, ibig sabihin, tama yung ginawa nating Gaussian Elimination. Tama yung nakuha nating sagot. Then, yung XYZ mo, okay? Yung matrix XYZ mo, or yung this matrix here, XYZ, will then be equal to 2, negative 1. So for further practice, I would implore you to try the Gaussian elimination method against the other examples given in the module. Okay? So that's it for this session. So this is our topic for the week. And if you have any questions, you may ask me through my communication channel, or you can schedule a consultation for it. Thank you. And see you all next week when we're back in the classroom. Bye-bye.